Hi, everyone. Can you hear me okay? Okay. I'm the chief architect at Forcepoint, and I'm going to talk to you about our dynamic edge protection service we've been building on top of AWS. And mostly I'll be talking about why we use AWS and how we utilize it to solve some of our challenging problems. So a little bit about Forcepoint for people who don't know us. We're one of the top cybersecurity companies. We have over 1,300 customers, both in the commercial and government space. We have over 2,700 employees in 50 sites, 50 plus sites spread around the world. And we have a lot of technology we have from companies we've acquired over the years. We have data protection, network security, endpoints, and we're taking all of these and building cloud-first solutions where people can pick and choose what security features they want and kind of solve their cybersecurity problems. And I'm going to talk about one specifically. So dynamic edge protection, sorry, I'm not doing well with the microphone. For dynamic edge protection is really about providing network security in the cloud where you can compose what you want with the various pieces. If I want DLP, I want CASB, I want web filtering, I can pick and choose all of those and build a solution that solves my security needs. So what we're trying to address is the evolution of how companies are consuming security. In particular, kind of old style, I used to have a data center in my headquarters where I would backhaul all my traffic to my apps. But what we're seeing is as everyone's moving to SaaS solutions, more and more traffic's going to the internet, and it doesn't make as much sense to backhaul everything. And prior to this, I had a bunch of security services. I'd buy firewalls, I'd buy IPSs, run them in my data centers, and backhaul all my traffic and then send it back to the internet. But as I'm using more and more cloud services, I'm just backhauling traffic that should be going to the internet directly. And so what we want to do is offer a SaaS service where I can get the same security functionality, but offer it purely as a service living in the cloud. And so kind of the evolution of this is I have all the headquarters, I have the branches, and even roaming users all connect directly to the cloud. So when I want to consume security services, we take all the traffic, send it directly to the cloud. We perform the security content inspection, and then go directly to whether it's Office 365, AWS services I'm running up there, or just the internet in general. And part of the reason that you give it in the cloud is it helps you solve a bunch of problems that are much harder when you have many sites and many locations. One is you want to do your basic security thing, manage risk, right? I want to stop drive-by downloads, downloading malware into my laptop, going to phishing sites, these sorts of things. Additionally, I want to streamline, how I manage and promote consistent security policies. For example, Larry Houston has some security policies I apply to me, right? So it should be the same when I'm sitting at AWS VPNing in. I go to our Cork office or I go to our headquarters in Austin. I want the same security policy applied to me no matter where I am. And moving this to the cloud makes this a lot simpler because we've now you have a centralized control plane and we know who the individual user are. We can apply this to all the traffic that's coming from that user. Whereas when you have disparate data centers with individual stacks, it's much harder to keep a lot of that policy, in sync, and also then reporting on it is much more difficult too because you end up with your user activities spread all over the place. So what we want to do is pull that all back together. It also kind of from a user perspective, it helps reduce some of your costs and make them easier to scale, right? So when I'm buying boxes and deploying them on-prem, I got to figure out, okay, what is my capacity 3 years from now? Because I don't want to buy a box now, find out it's too small, and tell my box I need to buy the bigger box next year, right? So you end up overbuying capacity. But when you start consuming it as a cloud service, you can buy the capacity you need, and it's much easier to add capacity as you go forward. And then the other thing you can do is now you have a much better view of what users do as they move from mobile users where they're using VPNing in, they're working on site, moving there, I now get a good view of all of their activity, and we can start bringing in behavior. And one of the things Forcepoint really focuses on is user behavior. So we're looking to see, what do you do? Is this typical for what you do, or is it different from what you do? And how does it compare to your peers? So we can decide if your change in behavior is risky. Is it because your laptop's infected? You may see a change in behavior. Are you, thinking about leaving the company, and all of a sudden you're downloading data from Salesforce I have never looked at before? And all these things, by looking at behavior and understanding this, we understand better what's going on and can secure your network better. So why do we use AFS? Well, first and foremost, we're a security company. We want to focus on the security aspects. But offering a SaaS service, there's a lot more to it than just saying, okay, I have a firewall and an IPS in the cloud, right? I need to perform reliable failure handling. I need backup. I need to back up databases and restore them. I need disaster recovery. All of these things, which you can think of as, they're kind of commodity, but commodity doesn't mean they're easy, right? So backing up a Postgres database. I've worked in companies where we've done our own backup systems, and I have a lot of horror stories to tell you about cases where, the backup worked fine, you just couldn't restore from it. And so what we want to do is focus on, AWS can really focus on this because they have a ton of people using RDS. And they can be experts on, okay, Postgres updated and it broke up the snapshotting and stuff. They will go and fix that problem. If you do it yourself, you're going to spend a lot of time saying, oh, this doesn't work very well, or we didn't notice this until some customer ran into a problem and Amazon solves this for us. And you can look at a lot of different things like failure handling and recovery that they do much better than you're going to do as a side job. The other thing is the relentless innovation, right? People went to the keynote, they announced all sorts of new products today, right? They're constantly improving their service, and we can use those features to make our product better. In particular, look at kind of just even the move to serverless, how much they've helped from our standpoint of focusing on the security aspects. A few years ago, Amazon, you thought of them primarily as running VMs and storage in the cloud, right? So it was nice, but now you have things like AWS API gateways, where I just write the functions to perform the API checking. I no longer need to worry about, patching OSs, making sure they're up to date. AWS handles all that for me, and that lets us focus more on the security aspect and less on the day-to-day running of the service. So here I'm going to talk about three kind of main things that we use from AWS and how we go about using them. There's a lot more to our services, but one of them is advanced networking. We service very large global customers. We need a global networking footprint so we can reach those customers. We have a wide range of telemetry we gather from our service. So we have user telemetry that tells us about all the user activities. We want to understand behavior, so we need to gather all this data and run advanced analytics on it. And then you have things like security telemetry, where we have security feeds, we're blocking stuff in the product, so we need to know, what are we blocking? Are we blocking the right thing? Are there new threats we should be aware of so we can develop new countermeasures for them? And similarly, we have governance and compliance, right? Customers are now sending their traffic to the cloud and their logs to the cloud. They need to know that they can trust that that data is safe and protected. So how we use AWS to ensure that, we'll touch on in a minute. So advanced networking. So the way we run our service, our networking service for Dynamic Edge is kind of over there in the middle, right? We create different regions where we kind of replicate all of everything that's needed to process the traffic in each of those regions, so they can operate independently. If one region goes down, the other one can pick up from it, right? So inside there, this is kind of a high-level abstraction. I'm not going to get into the gory details, but you can think of, we have AMIs running in there, we have Lambda functions, we have other processing running in there, but ultimately the user needs to get their traffic to one of the regions. We process it and send it to the internet. To make this work, we use Route 53. They create an IPsec tunnel. It does a domain lookup, And we'll use geolocation to get us to the closest data center, which AWS has a great global footprint, so we can make sure that their traffic is processed very close to where they're located, right? And the nice thing with AWS is they keep expanding too, and they have the major population centers, and we can keep following them and leveraging them as they do their investment, right? So you reduce latency. We also then can use Route 53 to also give us failover as well, right? Because we have these replicated instances. If one of the regions go down due to a fiber cut, due to software failure, both, failure detection in Route 53, as well as our own monitoring, we can pull locations out of Route 53. And if it goes down, the IPsec tunnel will go down, they'll do a new DNS lookup, and they'll fail over to the other region, and the underlying infrastructure will reconnect, and seamlessly the traffic will keep flowing without them knowing about the outage. The other thing we're using fairly heavily is Bring Your Own IP, which is a new feature they finally rolled out last year. And over here you can see we have a box in there that's a NAT gateway. And we kind of leverage the BYOP there, so we use our own address space within the network. So we can say, this solves a couple problems for us. One is just reputational. So traffic, after it comes from the customer, it goes out with one of our addresses on it. So if it gets blacklisted for some reason, we can manage that blacklisting, and being the owners of the IP makes that a lot easier. It does happen when you have SaaS service. The other thing is like localization challenges. So you have a data center running in Brazil, but from Chile is connecting through them. If they go to somewhere like Google News, they're going to end up with, and has the Brazilian IP, they're going to have content localized for Brazil, which is not what they want. By using BYOP, we can use address space we've registered inside Chile and map the customer's traffic into that, so when the traffic goes out, it looks like it's coming from Chile and it gets localized correctly, right? So you end up having happier customers, which is fundamentally what keeps them on your product. The other thing we talked about was analytic infrastructure, right? So this, again, is a high-level overview. We're heavily leveraging Kinesis data streams. We have some services that can send it there directly, as well as we have Amazon Kinesis that feeds, Firehose that feeds it into Kinesis data stream. And from there, we can have different services pick off the data and perform analytics on them, right? So, and some of that we're doing with Lambda, some we're using Kinesis data analytics, and all of these give us different ways to kind of solve the problem. And you have different teams that are running analytics, so having kind of this flexibility makes it very good, right? You have the security team that's doing security analytics. We have a whole human behavior team that's looking at, user behavior and understanding that. So they can, do it in their way, and it gives us a lot of flexibility in how we do the analytics, because not necessarily one size fits all. And then on the back end, once we're done running the analytics, we can store those results. And again, there's different data requires different access patterns and different types of data. So Amazon gives us a very rich set of features that we can utilize for this. At one end, we do just raw data, so we store data into S3. We need this both for researchers because they want to try new analytic algorithms where they want to take the log and run through and compare it to the analytics we got in our current product to see how it would differ. You also have things like I want to put it in Elastic because it's easier to visualize in there. You may want to do DynamoDB for much better indexing and efficiency for kind of binary data and reporting. But the nice thing is then we can have all these. Then you can use Amazon API Gateway, so we sit in front of all these and we can control access to all the raw data, which kind of leads me into the governance piece. So as I mentioned, our customers need to be confident that we're protecting their data, right? So they have sensitive data that's going there, including some government data. And AWS has a shared responsibility model where they provide a bunch of certifications for the core services, and we don't need to worry about doing that ourselves. So we can use RDS. It's already has SOC certification. It has ISO certification. We don't need to say, we don't install Postgres and include that in our certification. We just have to say how we're using it and make sure that we're following the appropriate controls for the various certifications there without going down into all the individual components, which in the end saves us a lot of work. Especially when you start talking about patching and stuff, they do all of that for us. The other key piece here is, they have really strong identity and access management. And this is really important, especially when you start thinking about like log data, right? So we have all these user logs, we have user activities, and they're covered for lots of things. There's just the general privacy, there's GDPR. But the nice thing is with the IAM, you can really lock down access and assign roles so you can do fine-grained control. You can say, okay, we're storing all these logs here, and these are the only services that can touch them, like the API gateway and the analytic functions themselves. There's no other way to exfiltrate data from there that doesn't violate the IAM policies. And then because our one way in is through the API gateway, we can do detailed logging, dump that into AWS CloudTrail, so we can audit that all the way through, as opposed to if we just had an NFS server sitting there and we're kind of just hoping no one was actually accessing it through the ways they shouldn't, right? As I mentioned, building enterprise security service is challenging, right? The security is the small portion of the problem. Embracing AWS has really reduced our overhead here, and I think it will continue getting better as time goes on and they introduce new services. The thing is, AWS provides many different tools. Sometimes when you're starting out, there's a challenge in that choosing the right tool in the design can be a bit overwhelming. And one thing is partnering with AWS and the solutions architects can really help you here. And I highly recommend if you aren't, you do engage these people because they can greatly help your your progress and make sure you're following best practices. So that's it. Does anyone have any questions? No? All right. And I'm supposed to remind you all to please fill out your survey.